All right, guys, we're on the back side of Unit 8, Day 1 notes. And I kind of scrolled down a little bit so I can see my graph and my questions at the same time. And number 5 says, given f of x shown above, find the following. Find the zeros. So instead of giving us the equation and having us algebraically find them, now they give us a graph. So we have to be able to go both ways. So remember, zeros are where they cross the x-axis. There are solutions or our x-intercepts. They also call them roots, and we have one here and one there. And so this one's at -1, and this one is at +1 to +3. So we're going to go ahead and say x equals -1. Okay, and we can also say x equals 3. We could also write that as x equals, in squigglies, -1 comma 3, if you don't feel like writing x equals twice. Okay, they also ask us if they are real or non-real, and since that we can really see them on the x-axis, we're going to go ahead and say that these are real roots. Okay. Part B says, what is the axis of symmetry? And the axis of symmetry, every parabola is symmetrical, and it's always a vertical line for our parabolas that open upward and downward. And that red dashed line right there would cut that parabola equally down the middle there, so that the left side would fold up onto the right side if we fold it along that dashed line. And so that's the axis of symmetry. Because it's a vertical line, always think of Vux. So you know that it's x equals, and it looks like it's passing through +1. So we would say the equation of the axis of symmetry is x equals 1, which is a vertical line. Part C. Over what interval is the graph decreasing? So remember, you always read from left to right. Okay? As you go from the left side to the right side, we are going up, and so this would be increasing. And then this one here would be decreasing. And they want to know decreasing. And remember that it's always x values when we write our interval. So the first x value that it starts its decreasing at is +1, comma, and it continues to decrease, right, as it goes towards positive infinity. All right, so remember they're x values. So this is an x value of 1, and it keeps going as we go towards the right side, which is infinity. So from 1 to infinity are our x values that it's decreasing over. Also remember, increasing and decreasing are always round parentheses. Always round. Okay, so you shouldn't have to think about it. All right, part D says, what is the maximum value? So remember, absolute maxes are y values. And so this is the highest y value, and that is at 1, 2, 3, 4. So our maximum is 4. Okay, we're going to go ahead and skip E. We cut that out for this year. And we're going to go to F, and it says determine the end behavior as x approaches infinity. X approaches infinity is on this side, so we're looking at this end. And we're going to go ahead and say that f of x is approaching negative infinity since it's going down. Okay? And then part G is going to ask us to write a possible equation for f of x. So I'm going to go ahead and move my paper down. Okay. Remember that on the front side, given the equation, we factored it. We did our t-chart, and we got solutions, right, which are where our roots. So now we're going to go backwards. We're going to take our roots, which are x equals -1 and x equals 3, and we're going to go backwards back to the equation. And they say a possible equation because there's many equations where this, where a parabola can have these two roots. Okay, so that's why they say a possible one. So we're going to go ahead and take our solutions, our roots, and turn them back into factors. So remember that before it was x equals -1, the 1 was on this side, but if you want the 1 to go on that side, you have to make sure you do the opposite of it. And so if we added 1, it would be x plus 1. Okay. So this used to be x plus 1 equals 0. And that's how it became x equals -1. All right. This one used to be x minus 3 equals 0. And so our other factor would be x minus 3. And the whole thing would be equal to 0. All right. So hopefully that wasn't too tricky, but going backwards sometimes can be. All right, now we're going to go ahead and put them back together. So the opposite of factoring is distribution. So we're going to distribute these back together. Some of you might find the little box to be helpful to put them back together. It's up to you. Okay, you can fill in the box, or you can double distribute like I'm going to do. X times x should give you x squared. This one should give you a minus 3x. This one here should give you a positive 1x. And this one here should give you a minus 3. Same 4 terms you should get from the box. Okay, and then we're going to go ahead and put 2 of them together in the middle there. They're like terms. And so this is going to turn into x squared. Negative 3x plus 1x is negative 2x. And then minus 3 equal to 0. All right, we have one little thing to fix though. If we were to graph this parabola, okay, that we just got this equation for, you're going to notice that he's a happy parabola. And if you look up at our picture, it's a sad parabola. So what has to happen is that we have to go through and distribute a negative, okay, to every term. So I'm going to go back, get rid of this little arrow here. And I'm going to go ahead and put this negative here and put my whole parabola there, whole equation in parentheses. And we're going to go ahead and say that f of x is equal to negative x squared plus 2x plus 3. And that would be the equation for f of x. Okay, if we graph that, it should be a sad parabola instead of a happy parabola now. And it should have 2 roots, one at -1 and one at +3. We could check it in our calculator as well. All right, let's go ahead and take a look at number 6. I can move mine over. There we go. All right, and it says given g of x shown above, find the following, find the zeros. So we have a 0 here, and that looks like it's at +2, and we have a 0 here, 3, 4, 5, and that one looks like it's 6. So we're going to go ahead and say that x equals 2, 6. All right, part B asks about the axis of symmetry, and so the line of symmetry would be along this vertical line here. Because it's a vertical line, it's going to be x equals, and it looks like it's going through 4. All right, part C says over what interval is the graph increasing this time? So if we read our graph from left to right, this part is going down, so this will be my decrease. And then it goes up, and so this will be my increase. And they want to know the increase one. So what x value did I start increasing at? I started increasing at 4. And I didn't stop increasing. I keep increasing, and that's an x value of infinity. Remember, always round, like we said before. Okay. Part D wants to know the minimum. Okay. Our minimum, remember our y values. And our minimum for this one, that's the lowest this graph goes, which is 1, 2, 3, -4. Okay, we're going to go ahead and cut this one out. And then part F says determine the end behavior as x approaches -infinity. As x approaches -infinity for x's is over here. So we're looking at this end. And we're going to go ahead and say that g of x is approaching, and it's going up. So we'll say infinity. All right, so now they want us to write a possible equation for g of x. Move this down, hopefully. There we go. I got to make sure I know my roots, and we're going to go ahead and work backwards, just like we did. And you don't have to write it backwards like I was doing. You can write it normally. I was just showing you a strategy if that helps you think better. So I'll show you what I would do normally too. So if I have x equals 2 and x equals 6 as my roots, I'm going to work backwards. Okay? And I'm going to go back to what they used to be as factors. And so this used to be x minus 2. And this one used to be x minus 6. and the whole thing used to be equal to 0. And now I'm going to go ahead and put them back together. And again, if you need the box to put them back together, you can use the box. It doesn't matter to me. This is going to give you x squared. This is going to give you a minus 6x. This one's going to give you a minus 2x. And this is going to give you a plus 12. Two middle ones are alike, and so we'll say x squared minus 8x plus 12 equals 0. Going back up, remember our parabola opened upward, and so we want a positive x squared term, so we do not have to distribute it through a negative. But if you do want to check it, you can go and put this in your calculator and double check that it looks like what you were given. Okay. Sometimes it won't look exactly what you were given as long as it has the roots, and that's why they say a possible equation. Sometimes the picture doesn't match exactly, but as long as the roots match, and the parabola either opens upward or opens downward and matches. Okay. All right, we have one last question. Here on the bottom, they're asking me to write a quadratic equation in standard form given that it has zeros of -8 and -3/4. So it's the -3/4 that's a little bit different for us, but hopefully we'll be okay. Again, they want us to write an equation, and so we're going to go ahead and say that x equals -8 since our equations come from the roots. Okay. And x equals -3/4. All right, so the x equals -8 used to be x plus 8 as the factor. This one's going to be a little bit trickier for some of us. What we have to do is we have to undo. So the division gets undone first. And so when you divide by 4, the opposite is multiplying by 4. And so that would become a 4x. The opposite of the -3 would be +3. And so this is what actually the factor looked like before it became that. You guys can kind of see that if you go, this way. But you would subtract 3. That's how the 3 got negative, then divide by 4. So it was 4x plus 3 before it became x equals -3/4. And that's going to be a little bit tough for some of us. All right, so now we're going to go ahead and distribute. And x times 4x is 4x squared. X times 3 is positive 3x. 8 times 4x is positive 32x. And 8 times 3 is positive 24. And we're equal to 0. Okay, we're going to just go ahead and combine our like terms. So we'll keep the 4x squared. 3x and 32x is going to become positive 35x. And plus 24 equals 0. And this one we don't have a picture to match, so we have no idea if it opens upward or opens downward. And so this is one possible equation that has these zeros. Okay, and we could double check in our calculator if we wanted to. All right, guys, I'll see you guys on the next day of notes.